Me di una sirimba un domingo en la mañana cuando menos lo pensaba. Caí redondo como una guanábana sobre la alcantarilla.
So, what is energy? Well, energy is a central concept underlying all of science.
Pues energía es el concepto central dentro de todas las ciencias.
We get energy from the sun, which then transfers it into different objects that distribute it.
La energía proviene del Sol, y ésta se transfiere a diferentes objetos que la distribuyen.
In physics, energy is the ability to do work, which causes a change in motion.
En física, la energía es la capacidad de hacer trabajo, la cual causa un cambio en un cuerpo.
This transfer of energy is called work.
Cuando la energía se transfiere, obtenemos trabajo.
Work is a product of the net force of an object and the distance through which the object is moved.
Trabajo es el producto de la fuerza neta de un objeto y la distancia que él mismo recorre.
Since work uses the unit of force, which is newtons, and the distance, which is meters, the result of work is newtons per meter, which is also called joules.
El trabajo utiliza las unidades de fuerza, newtons, y la distancia, metros. El resultado del trabajo son newtons por metro, también llamado julios.
Another category of work is the one that changes the speed of an object, whether it's accelerating or slowing down.
El trabajo también cambia la velocidad de un objeto.
Now we're going to do a problem using the work equation. So we know that Janina had already traveled 70 meters before she decided to stop. If she applies a negative 5,000 newtons of force on the brakes and the total distance of the road is 100 meters, what's the total work? So we know that work is equal to force times distance. So we know that the force is negative 5,000 times the total distance. So if we don't know the distance yet, then we have to subtract it. So if the total distance is 100 minus 70 meters that she's already traveled, we have to subtract it, which equals 30 meters. So you multiply times 30, and the work is equal to negative 150,000 joules. In order to figure out how long it takes for something to do work is by finding the power.
Para saber cuánto tiempo tarda algo en hacer trabajo, calculamos la potencia.
The basic definition of power is the rate at which work is done. In other words, how long it takes for energy to get transferred.
Potencia es el tiempo que tarda la energía en transferirse.
Okay, so in order to see which one has some more power on the this problem, we're going to use a time of 5 seconds and 3 seconds. So we know that Janina goes up the stairs with a force of 100 newtons and a distance of 3 meters in both. So in order to find it, we do 100 times 3 divided by 5, which equals 60 joules. And then on this one, it's the same thing, but over a period of 3 seconds. So these cancel out, and it's 100 joules. So we know that this one has the greatest power because it's more joules. When she spends more time going upstairs, the power is lower than when she spends less time.
Cuando ella tarda más tiempo en subir las escaleras, su potencia es menor que cuando ella tarda menos.
The energy acquired by the objects upon which work is done is known as mechanical energy.
La energía adquirida por los objetos, mientras que el trabajo es hecho, se llama energía mecánica.
The total amount of mechanical energy is merely the sum of the potential energy and the kinetic energy.
La cantidad total de energía mecánica es la suma de la energía potencial y cinética.
Mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Mechanical energy can be either kinetic energy, which means energy of motion, or potential energy, which means stored energy.
La energía mecánica puede ser cinética, energía del movimiento, o potencial, energía acumulada.
The energy associated with the work done by the net force does not disappear after the net force is removed, or becomes zero. It is transformed in the kinetic energy of the body. We call this the work energy theorem.
La energía asociada con el trabajo hecho por la fuerza neta no no desaparece una vez que la fuerza ha dejado de actuar, sino que ésta se transforma en la energía cinética del cuerpo.
The law of conservation of energy states that the total amount of energy in an isolated system remains constant over time.
La ley de la conservación de la energía establece que la cantidad total de energía en un sistema aislado permanece constante en el tiempo. So now we're going to do an exercise using the law of conservation of energy. Janina lifts her 2 kilogram ball 2.8 meters straight up. She lets it drop to the ground. Using the law of conservation of energy, we are going to find how fast the ball will be moving halfway down. So what do we know? So we know that the initial energy is going to be equal to the final energy. So in this case, at first, the ball has only potential energy, but at the end it's going to be kinetic. So the initial potential energy equals to the final kinetic energy. We know that potential energy is mass times gravity times height, and that equals the kinetic, that is 1/2 of the mass times the velocity square. So we put what we know. We know this, but we need to find the velocity. So we solve for velocity, and then we have mass times gravity times height over 1/2 of the mass. Since the mass is 2, 2 over 2 is 1. Then we have mass, that is 2 times gravity, 9.8, but we are going to use 10 times the height. Since the total height was 2.8 meters, halfway down it's going to be 1.4 meters. So 1.4. And that equals 529 meters per second. And we found this using the law of conservation of energy.
During the transformation of energy, some of the energy will be usefully transferred by the device and some will be wasted, which means transferred to a non-useful form. Eventually, all the energy will go to warming up the surroundings.
Durante la transformación de energía, parte de la energía será transferida y utilizada, pero otra parte será malgastada. Entonces, esa energía malgastada, entre comillas, estará calentando los alrededores del objeto.
"9 p.m. The streets were meaner than a Rottweiler with a migraine. I had a hunch energy was being lost in this town, and I was investigating where it was going. For I am
the energy detective.
I'd had a tip-off I should watch out for Debs McGrail. Said she had useful information I might find useful. Suddenly I saw her.
Debs McGrail?
I've been expecting you.
I've heard that there's energy being lost, and nobody loses energy in my town.
You've got it all wrong.
Listen, lady, don't play the fool with me. Losing energy is a crime. And besides, it's wasteful.
But you can't lose energy. When you use it, it just gets transferred. Don't you understand?
You're asking if I, the great energy detective, don't understand? Actually, I don't.
Take your car. The energy comes from the petrol in it. What you want is for that energy to be transferred into movement or kinetic energy.
Sure.
But only 30% is transferred into movement.
30%? That means I'm losing, a lot.
But that's the point. It's not lost, it's just transferred.
What to?
Mainly heat. Parts of the car heat up, engine, tyres, and they heat the air and road around them.
The exhaust pipe heats up too, and that heats the air. Then there's sound. That's energy being transferred to particles of air, which vibrate and carry the sound to you.
Wow.
But here's the main point. If you add up all that the energy is transferred into, it's the same as the energy that was put in. Nothing is lost.
It was all too much. I felt in need of a science in action graphic.
I got it.
If the total available energy is 100%, the useful energy is what goes into movement, 30%. The rest is energy that gets transferred into things that ain't so useful. So nothing is lost, just changed.
I was beginning to understand. But surely there's a principle at stake.
You can't create or destroy energy. It just gets transferred. It's called the principle of the conservation of energy. It's not lost or destroyed.
See, there was a principle at stake. So, only 30% useful energy from my car. That's not very good, is it?
And as for that torch,
Not my torch.
the energy in the batteries is transferred into useful light and useless heat.
I prayed she wouldn't tell me what the useful energy was.
Useful energy, 5%.
She told me.
We said our goodbyes and I went back into the night. Now I knew of all the energy in all the towns in all the world. None of it was ever lost.